I am recording. I want to start out because of a question that I've gotten on the homework for continuous distributions. And I was just wondering if some of you had a similar question. There's, I think, two questions that deal with the uniform distribution. And they ask you, they're multi-part questions, and they ask you to find scores that are like above the upper quartile or something like that. They use the word quartile. Okay, I'll put that word in the chat. Okay, quartile. Quartiles are special percentiles. Okay, so your lower quartile is the 25th percentile. And we talked about percentiles last time. Percentiles are just telling you what percent of the scores are below that particular value. So the lower quartile is your 25th percentile. The upper quartile is the 75th percentile. Okay, and basically lower quartile, a score at the lower quartile boundary means 25% of the scores are below that. Score at the upper quartile boundary means 75% of the scores are above that. And again, the median is sometimes called the middle quartile. Okay, and as you know, it's the 50th percentile because half the scores are above it and half the scores are below it. Okay, so that's just some terminology. Those homework problems that do use that quartile terminology have a hint at the bottom. Okay, so click on the hint and it will bring up a pop-up box that will explain all of this to you. Okay, so in case you forget, what we're talking about now, the special vocabulary, just make sure when you're doing homework, use all of the tools that are available to you. If they give you a hint, like you see a little link at the bottom that says hint, click on it. Okay, they might be giving you some information that makes the problem easier to solve. However, if you still get stuck and have questions, feel free to ask. Okay, so what we're going to be doing this week is we're going to be spending this class session talking a little bit more about the normal distribution because it's so widely used. And we're going to talk about a way to convert normal distributions that have means and standard deviations that aren't 0 and 1 to standard normal deviations. Now, you have to understand a lot of this stuff that deals with the normal distribution has some historical baggage that goes along with it, in the sense up until about 20 years ago, there were no calculators for doing normal distribution. You pretty much had to look numbers up in a table. We are not going to do that, okay? We're going to use online calculators to leverage off the arithmetic and the table lookup stuff. So I'm going to show you, I pulled a selection of online normal distribution calculators that I've linked to in our course for those of you who don't have a TI-84. And of course, for those that do, I can quickly show you how to use the TI-84. But in a lot of instances, the online calculators are much easier to use. So again, I'd encourage you to leverage your calculating onto that. So as always, if there are no questions right now, okay, I'm not seeing or hearing any questions. I'm going to move on to sharing my browser with you and showing you where we're at. Okay, so we are currently in, believe it or not, week 13 of our course. This course has 15 instructional weeks and 1 week for the final exam. So there are 3 more instructional weeks, 13, 14, and 15, and then there's a final exam week. So we're about 4 weeks from the end of the course, okay? As we've mentioned a couple of times, it's a great idea to try to catch up on stuff that might still be outstanding that you want to work on. Remember, the first half of the course, weeks 1 through 8, are wide open. Okay, you can work on any of those assignments without a late pass. For the second half of the semester, weeks 9 through 15, you will need late passes to open up past due assignments in more. Okay, the late passes only work in more. Okay, the stuff that's in Canvas will let you submit it late. Okay, so if you missed a discussion and you want to participate in it, you can submit your post late. Okay, so again, I'm trying to make sure everybody has a clear understanding of what needs to be done by, what's the date? May 14th. Okay, Friday, May 14th is the day all the assignments except the final exam close. Okay, and then our final exam is the following week. Okay, again, try to accommodate the crazy situation we're in and the technology outage that we had. So if you're still struggling, please let me know. Okay, reach out to me, shoot me an email, and we'll work something out to try to, get you caught up if that's the problem you're having. So anyway, this week we're handling z-scores and normal probabilities, and I'll be using this notes file right here in today's class. You can see I've linked a bunch of online normal distribution tools into this week. They are also in the online tools and calculators module that's near the bottom of our Canvas course, so you don't have to search for them. And again, I want to also show you, we have an exam coming up. Okay, it's going to be due by this Sunday, May 2nd. So what we're going to be doing on Wednesday is going over a practice exam. Okay, so what I'm going to do is print out my practice exam, okay, from more, and then we'll walk through that one. Will yours be exactly the same? No, okay, but it'll be exactly the same kinds of problems, okay? So remember how this works. There's a practice exam that you can do as many times as you want, okay? And when everybody's done, when the due date passes, I will give everybody the 20 points for this practice exam, regardless of what you scored on it. So your score on the practice exam will not influence your grade negatively, okay? The real exam, the actual one that you take once, is this Unit 3 exam. Okay, and it covers everything on probability that we've done so far, probability and statistics. Okay, and again, it's due at a minute to midnight on Sunday, May 2nd. Please don't wait until like 9 o'clock to do the exam. And here's the Unit 3 exam work. When you're done, okay, take photos or scan in your work and upload it, okay? Just so you know, some of you have been saying, I can only upload one picture. Well, you should be able to upload multiple files, okay, to the exam work. But if you don't want to do that, there are apps, free apps online that will let you take a bunch of photos that you've taken with your phone and create a PDF that you can then upload. Okay, so however you do this. Okay, so anybody have any questions on any of where we're going? Okay, so today we're going to be talking about z-scores and normal probabilities. All right, so I'm going to be opening these notes. If you've got questions, feel free to unmute or put them in the chat. Give me a moment to upload, to open this file. Okay, and let me share this file with you. All right, everybody should be seeing section 3.6, z-scores. Okay, and it's more than just z-scores. Okay, so we'll talk about this as we go along. And again, I want to just make it clear to you, I do not expect you to do calculating by hand. I expect you to leverage technology either on your TI-84 or using the online probability calculators I've provided in the course. Okay. So z-scores are something that are associated solely with the normal distribution. Okay. And when you get into the inferential statistics in GBS 221, those of you who are going there next, you will see z-scores a lot. Okay, you'll see z-scores a lot in helping you to decide whether or not you should accept or reject hypotheses. Okay, what is it? Well, it's a measure of relative standing. Okay, Another way to put it is, if you have a normal distribution with a given mean and standard deviation, the z-score is, if you were to convert that into a standard normal distribution, it tells you what your standard deviation is. How far away from the mean is that score? Okay, so it's like a standard deviation in a standard normal distribution. And you might remember from last time, standard normal distributions have a mean of 0 and a standard deviation of 1, okay? The only thing they're useful for is, again, in finding out these particular probabilities. So back in the day, what everybody did was they took their scores and their normal distribution, they converted it to the standard normal distribution, and then they looked up the probabilities in a table. We don't need to do that, okay? Because we have calculators that can handle a normal distribution with any mean and any standard deviation. All of these calculations I'm showing you related to z-scores are happening behind the scenes in the software, okay? Now, that doesn't mean you can ignore them. It's a good idea to understand what calculations are going into the technology you're using. That's going to be especially important going forward with inferential statistics. Okay, you're going to need to know, if I change this particular input to this calculation, what happens to the output? Okay, and again, you just have to figure out, you just have to understand how those inputs affect the outputs. You don't need to do the calculation yourself. Hopefully that makes sense. All right, and helps you estimate whether your answer, or judge whether your answer is a reasonable answer. Okay, and that's really important when you're using technology. Okay, so a z-score tells you how many standard deviations the value is from the mean in a standard normal distribution. Okay, so here's how you calculate the z-score. Okay, you basically take the, subtract the mean from the data value. So X represents the data value that you're interested in. You subtract the mean of the distribution and you divide it by the standard deviation of the distribution. That's what all these Greek letters mean. Okay, and that's how you calculate a z-score. All right, one of the things I've put into the course, okay, let me just show you. Okay, see z-score calculator. Okay, I have that up and open. So again, hopefully I can show you that, but again, this toolbar is always in the way, so there's no way for me to, okay. Here's the z-score calculator. Okay, you put your raw score in here, the population mean, mu, the standard deviation, and it'll tell you the z-score. Okay. The only mistake people make when they actually calculate the z-score is they have a nasty habit of always wanting it to be positive. So they switch X and mu. Don't switch X and mu. Okay. You always want the data value first and the mean second, because for data values that are below the mean, you want to get a negative z-score, right? Negative standard deviations below the mean. Okay, for data values that are higher than the mean, you want a positive z-score. Okay, so let me just put this here, negative values. Below the mean. Okay, and positive z-scores are above the mean. Okay, so don't mess with the order in that subtraction. It's important to leave it that way. Okay, so let's take a look at, what z-scores can tell you. Z-scores are particularly useful in descriptive statistics when you have distributions, two different distributions, and you want to compare scores in the different distributions. Here's an example of that. Suppose two graduating seniors, one's a marketing major and one's an accounting major, are comparing job offers. The accounting student has a job offer for 45,000 a year, and the marketing student has an offer for 43,000 a year. Okay? Accounting job offers have a mean of 46,000 and a standard deviation of 1,500. Marketing job offers have a mean of 42.5 with a standard deviation of 1,000. Calculate the z-scores for each job offer and compare them to determine which is the better offer. Now we're going to talk about better. This is a subjective word. Okay? What does subjective mean? Anybody want to tell me? What do I mean by subjective? Anybody want to shout it out or just type it in the chat? What does subjective mean? Anybody ever hear that word? Its opposite is objective. No? Anybody ever hear the term subjective? Okay. Well, all right. Well, one thing that you might realize is the word better is kind of a loaded word, right? You and I may not agree on what better means. Okay, you and I may not agree on what better means. It depends, right? Now, some people would look at this and say, oh yeah, the accounting student's definitely better off because he's making $2,000 more, she's making $2,000 more a year than the marketing student. But I would say to you, it depends on what are the salaries like in that field. Okay, this is the same thing that operates for those of you who are going on to ASU or U of A or NAU. You'll find out in universities, there's very often a curve to grades. Okay, so what determines that? It kind of is dependent on what the rest of the population is like. Okay, so for example, in university, if everybody gets a D on the exam, it's a pretty likely thing the professor's going to curve that exam and your D may become a B. Okay, I'll be honest, I never understood that. Why not just make a fairer exam? But that's the way it works. I can tell you from my own experience from 30 years ago that it works that way. Okay, so what I'm showing you here is, yeah, the accounting major is making more in absolute dollars, but let's take a look at the populations of salaries that these two salary offers are coming from. First of all, if we look at the accounting jobs, you can see our student is making less than the mean offer, right? Our marketing student, on the other hand, at 43 is making more than the mean. Okay, so that tells you right off the bat that depending on the population, it looks like the marketing student is doing better. Okay, but let's quantify this in terms of actual numbers. We'll compute the z-score for each student's salary offer. Okay, so I'm going to compute the z-scores. So here, z is x minus mu over sigma. Same thing for both. All right, and I'm just going to take the values that are given in the problem. Okay, and again, I'm just going to use 43 for 43,000. Okay, so 43 minus 42,500, that's 42.5. I scaled my values, okay, by thousands. And then scaling the standard deviation is 1,000. Okay, you can do that as long as you scale everything properly. Okay, so I divided everything by 1,000 here. And when I figure this out, I'm going to get a z-score of 0.5. Okay, it's positive, so it's above the mean. Okay, so this student has gotten a job offer that actually pays better than the average accounting student gets coming out of college. Okay, let's look at this. I mean, marketing student rather, coming out of college. Now let's do the accounting student. Okay, the accounting student got a job offer of 45, and the mean value in that field is 46, and the standard deviation is 1,500 or 1,500, 1.5 thousand. That gives me a z-score. Again, notice the numerator. You're taking a bigger number from a smaller number. So you're getting a negative value. Okay, so it's like negative 2/3. So this is below the mean. Right? So this student actually got a lower offer than the average accounting student gets. Okay? So I would say, based on the populations they're coming from, this student's got the better offer, right? Because it's above the mean offer in that population. Okay? Again, we're not comparing apples and oranges here. We're not saying that, you know, well, this guy should have gone into accounting. We're not saying that. Okay? We're saying that based on the population they're from, even though this offer has a dollar value that's higher, this one is positioned higher in its population. Okay, so everybody understand that z-score is a measure of position. Okay, understand that? Understand the z-score is a measure of position in the distribution? Yes? Can you give me some feedback, folks? Yes or no? Are we good? Okay. Again, I appreciate the feedback so I know whether to slow down, speed up, re-explain. I can't see all of you nodding or going to sleep. Okay, so give me some feedback. Okay, so again, a positive z-score tells you it's above the mean. Okay, that means higher than average. Okay, a negative z-score tells you it's below the mean, which means lower than average. And again, they don't always have a value associated with them. Like naturally, when we're talking about salaries, higher is better. Okay. But if we're talking about infection rates, then lower is better, right? So don't let, don't conflate higher or above the mean with good necessarily. Okay. It depends on what the distribution is about. All right. So pretty much that's where we are. And let's take again a look at our normal curve. Right. Okay. I think I have a problem here. Hold on. Okay. So this is how you do normal probabilities on the TI-84. Okay. So this whole thing is just showing you how to do normal probabilities on your TI-84. Okay. I want to just check over here, more practice. Hold on, folks, having some technical issues. All right. Okay, so on a TI-84, you have some distributions built in. I'm going to share my TI-84 with you for those of you who've got a TI-84, which I remember asking initially, and a fair number of you have a TI-84. Okay, so I'm going to turn this on. Okay, and then as far as a normal distribution, all your distributions are on your VARS key. See VARS up here? It's the shift or the second on that key. So second, VARS. And you'll see normal PDF, normal CDF. Okay. Because the normal distribution is a continuous distribution, okay, you want to use cumulative probabilities all the time, okay? So I'm going to choose normal CDF, okay? And let's take a look at this example right here. Suppose we want to figure out the probability of getting a score that's between the z-scores -1.5 and +2. Now that's like asking what percentage of this distribution is between 1.5 standard deviations below the mean and 2 standard deviations above the mean. Because again, remember, z-scores reflect standard normal probabilities. Okay, so again, I'm going to put -1.5 as my lower z-score, and I'm going to put 2 as my upper z-score. Okay, this is a standard normal distribution. Okay, so I'm leaving my mean as 0 and my standard deviation as 1, and the calculator defaults to this. Okay, and again, arrow down to paste, hit enter, and it puts it in your window. Now, for those of you who do not have a TI-84, you have a TI-83, or maybe an older TI-84, once you click on normal CDF, it's going to just open a set of parentheses, and you have to know the order of the parameters is lower z-score, then comma, here's the comma, okay, upper z-score, comma, then mean, comma, and standard deviation, and then close the parentheses. So that's the order, and this tells you what the order is, okay? Normally, when you use the TI-84 and you do normal probabilities, you want to round your probabilities to 4 digits, okay? So you'd have 4 decimal digits. Okay, so basically, oops, I'm sorry. My probability here, based on the normal calculation I just did, I would round this to be 0.9104. Okay, what does that tell you? That tells you about 91% of the scores are between 1.5 standard deviations below and 2 standard deviations above. Okay, if you want a picture of that, let me see if I can draw a picture of this for you. Okay, we have our mean here. Okay, here's +1 standard deviation, here's +2. Here's -1 standard deviation, here's -2. And yes, they keep going out. I just don't have enough room to draw it all. Here's my normal curve. Okay, and what I'm saying is, in this particular case, here's -1.5, and here's +2. Okay, I'm saying that the area in between here is about 91% of the area under the curve. Okay, so that's what that's telling you. Now, normal CDF will do that for you. Okay, if you take a look at the online normal calculator that I built into the course, you can see the same thing. Here's the normal distribution calculator. Okay, and it's one of the links in week 13. I'm going to leave a mean of 0 and a standard deviation of 1. I'm interested in scores between -1.5 and +2. Okay, and I'll click recalculate, and you can see I get the same probability. And what I like about the online calculator is it shows you the probability density function, and it shows you the area you're talking about. I like the visual feedback. Okay, so see how to use both normal calculators. Everybody good with that? See how to use both normal calculators? Okay, this one's really intuitive. You just have to pick the right button, depending on whether you want above that z-score, below the z-score, between it, okay, or outside it. Here's an interesting kind of riff on it, right? Here's the probability between, it's about 91%. If I click outside, I'd expect the other 9% in the distribution to be out there. Okay. And again, I want 1.5 and 2 as my cutoffs. And again, you can see with outside negative 1.5, my bad. And you can see there's the almost 9% that's outside in the tails. Okay, so I really like this kind of calculator because it's very visual. Right, so again, plug for the online normal calculator. If you like the ones on the TI, by all means use them. Okay. Okay, a lot of the directions in the notes, okay, will refer to the TI because that's what we all had when we were in class together. Since I know some of you don't have it, you know, that's fine. Okay. Now, if you're doing the TI, there's an extra little wrinkle that you have to worry about with the TI. Okay. And that's when you have infinite bounds. Like, for example, if you wanted to know what's the probability that a z-score is less than 1.5, okay, notice there's no lower limit on this. Whoops. Okay, so basically you're saying go all the way out to negative infinity. You have to fake the TI out in order to do that. So on the TI, okay, you need to fake negative infinity because there's no negative infinity key. Okay, so basically you have to pick a really negative number. Okay, so here's the really negative number, 1e, negative 1e 99. Okay, so that's a negative 1 and 99 zeros. So negative 1, blah, 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 99 zeros. Right? So negative a bajillion. Okay. It's kind of close to the most negative number your calculator can hold. Okay. It's nowhere near negative infinity. Negative infinity is not a number, right? It's a concept. Okay. But we can get a lot more negative than this. But as far as the calculator is concerned, that's negative infinity. So let's show you how to do this on the TI-84. Okay, I'm going to go back to second. There's normal CDF. And I'm going to clear out my negative 1.5, and I'm going to type in leading negative sign, 1. And then how do I get the exponent, right? This is scientific notation on your calculator. It means negative 1 times 10 to the 99th, okay? So you get it with this double E symbol above your comma. So second, comma, there's the little e, and then 99. Okay? And then you have 1.5 as your upper bound, same mean and standard deviation as before. Okay? So essentially what we're typing in is normal CDF. Okay, negative 1 E99 for the lower bound, which is like negative infinity. Okay, 1.5 is the upper bound, 0 is the mean, 1 is the standard deviation. Okay, that's the command we're using. We hit paste and enter, and you get, again, about 93%. Okay, 0.933, and I'll round that 1 to a 2 because of the 9 that's behind it. Okay. Now, on the other online calculator, you don't have to fake out anything. Okay, all you have to do with this calculator is click below and put in 1.5. Okay, it shows you what it's talking about when you hit recalculate. Here's 1.5, and you want everything. You get the same value. Okay, so no need to fake negative infinity in the online calculator. Okay, no need to fake negative infinity. Okay, so it's easier to use in that regard. Okay, and you can see exactly what you're talking about. This goes all the way out. Remember, the tails go on forever. Okay, everybody good with that? All right. Now, suppose we want the probability of being above 1.5. Here, you need to fake positive infinity. All right. And the way you do that is to pick a very large positive number. That's going to be 1E99. Okay. And that's 1 with 99 zeros. Okay. 1 with 99 zeros. Okay. So everybody understand how to put infinite bounds in the TI if that's what you're using? Okay, so I'm going to enter my upper bound as the one without the negative sign in front, 1E99. Okay, so what I'm going to type in, normal CDF. My lower bound here is 1.5. That's the smallest z-score I care about. Then 1E99 for my upper bound, 0 for the mean, 1 for the standard deviation. Okay, go over here to distribution, normal CDF. My lower bound's 1.5. Again, you've got to be able to handle the inequality symbols, right? Greater than and less than. Upper is 1. Second, comma to get the E, and then 99. Put it in your window and hit enter, right? And you should get 0.0668. Again, you can see these two numbers, if you added them together, should add up to 1, right? Because this is showing you the area under the curve below 1.5. This is the area above 1.5, and you know these two need to equal each other. Okay? Again, on the online calculator, it's as simple as clicking the above button, putting 1.5 in that box, hitting recalculate. Okay, and again, this is a great visual. Make sure you look at the curve and make sure you're seeing what you expect to see. Okay, all right, on these examples. On these examples, I want to make sure everybody can use the tools that are in the course. All right, I am missing a few pages, unfortunately. That's okay. We will manage without them. So let's take a look at some examples. All right. So again, we're going to calculate these z-scores and normal probabilities, okay, with calculators, okay? And these are telling you standard normal probability distribution. That means a mean of 0 and a sigma standard deviation of 1. You might have noticed your normal CDF and the online calculator will take any mean and standard deviation. Okay, so using those calculators doesn't require you to convert something to a z-score first. If you're not using a standard normal probability distribution, you can use those calculators right out of the box. Okay, so let's take a look at a few more standard examples though. And what I'm going to try to do for these is to show you what this actually looks like as far as the distribution. Here you're interested in z-scores between 0.5 and 2. Okay, so here's your mean. Oops. Here's your mean. Here's +1. Here's +2. -1. -2. And again, if you want to put the 3, you can do that. All right, and here's your curve. All right, so basically you're interested in what percent of the distribution is between 0.5, which would be about here, and 2. Okay, that's 1.5, my bad. Okay, so let's move it over. 0.5 is here. Okay, so here's 0.5 and 2. So you could see it's a fair chunk. All right, so how would I do that? Well, I'll show you on the TI. Well, I'll alternate these between the TI and the online calculator so you can get an idea how to do them. Here's VAERS, normal CDF. This is a between. So you can see my lower value is 0.5. My high value is 2. Mean is 0. Standard deviation is 1 because they told me it was a standard distribution. Okay, so I'm getting 0.2858. Okay, using your calculator of choice. Okay, they'll give you the same values. Here, you're looking for less than 1.5. Notice there's no equal sign here. Okay, it's important to realize with continuous distributions, there's no difference between less than and less than or equal. Okay, so there's no difference. I'm going to put it in the chat. Less than and less than equal. Okay, gosh, less than equal. That's what the last one was supposed to be, less than equal. All right, so you'll notice these don't necessarily have an equal sign. Don't fret about that, okay? It's the same probability. Because again, you're dealing with real numbers. There's no difference really in just leaving out one real number. There's still an infinite number of them left, okay? So it doesn't affect the probability at all. All right, so in this example, here's what we've got. Okay, we're less than 1.5, so here's our mean. Here's +1, +2, -1, -2. And again, I'm going to let you assume they go on in both directions. Okay, there's our distribution. We want less than 1.5. So here's 1.5. So we want all of this. And we kind of did this one already. Okay, and that was the one that was about 93. Okay, so that should still be in my online distribution calculator. That's this one, below 1.5, 0.9332. Ah, okay, 0. All right, everybody comfortable with that one? Then this one is greater than 1.5. We also did that one. So here's, again, it's important for me to show you what this means on the normal curve so you have a good idea of what these z-scores are telling you. Right, so again, it's too pointy for a normal curve, but drawing is not my forte. So here is positive 1.5. So this is going to be the remaining 6 or 7% of the curve on the other side. Okay, so again, if I go to my online calculator, and I click above, you'll see I get 0.0668. Okay, and the other one here is saying greater than 0.75. Well, again, it's just a matter of having things in the right place. This is +1, +2, -1, -2. Okay, so basically, if I'm talking about scores in a standard normal, this score would be 0. This score would be 1. This score would be 2. This score would be -1. This score would be -2. Okay, the standard deviations in the scores line up in a standard normal distribution. And you're asking, where does a score of 0.75 fall? Okay, well, here's my distribution. 0.75 is like right about here. And I want to know about the scores that are above that. Okay, so if I were to do that on my TI, second, oops, turn it on, second distribution, normal CDF. Okay, my lower value is 0.75. Okay, and my upper value is positive infinity, right? So 1 second E, right? To get second comma to get the E, and then 99. So all the way out in the tails, that gives me 0.2266. All right, and you can see again on my online calculator, all I would do is click above and change this to 0.75. Recalculate. Okay, so the online calculator is super, super easy to use. Okay. So everybody okay with the standard normal examples? Everybody okay with those? Anybody have questions so far? Okay, we're good. Yes, good. Okay. How about the rest of you? You all right? Okay. Well, the majority of normal curves you're going to meet in your lifetime are not the standard kind. Okay. Most have some non-zero value for the mean and some standard deviation other than 1. Okay. Now, either you have to convert your values to the standard normal values, or you have to let the graphing calculator or the online calculator know you have a different mean and standard deviation. Okay. We'll show you the old school value, the old school way first, which was converting your scores. You do not have to do this. Okay. So old school. Okay. No calculator. Okay, so basically what that meant was you'd convert your scores to a standard z-score, and then you'd look up the probability in a table. You didn't need a calculator. Okay, so that's how they do it here. And they say, suppose we want to find out the probability that our given x value is between 78 and 90 in a distribution that has a mean of 80 and a standard deviation of 3. Okay, so here's how they would do it. They would change the z-scores. Okay, so I'll just show you how to do that. All right, so the first one was 78. And sometimes they'll do this. The z-score of 78 in this distribution is 78 minus the mean of 80 over the standard deviation of 3. Okay, so that is a below the mean score. And it has a z-score of negative 0.667. If I want to find the z-score of the upper one, which is 90, That'd be 90 minus 80. This is an above the mean z-score divided by 3. And that gives you a z-value of 3.333. Okay? So basically, you would convert this to be for standard normal. You'd say this becomes the probability that your z value, and notice the variable is going to change from x to z. Okay, because z means standard normal. Okay, and then this is 3.3. Okay, you can see there's a lot of rounding here. Okay, so I'm going to do this on the TI because I can show it while I show my work as well. Right, so second, right, normal CDF. Okay, so I would say negative 0.6667 for my lower bound and 3.3333 my upper bound. Okay, and this is on the standard distribution. I get a probability of about 0.7471 if I round this 0 up. Okay, again, I'm keeping them all as 4 decimal places. Okay, but you can also do with normal CDF. Okay, you can write the original mean and standard deviation right in there. So I could do normal CDF, use my low cutoff, which was 78, my high cutoff, which was 90, but put the mean 80 in there and the standard deviation of 3. And I should get the same values. Okay, so your calculator allows you to do this. Second distribution, go here, normal CDF. All right, and my low score was 78, my high score was 90. The mean of the distribution is now no longer 0 because it is not the standard distribution. It's 80, and my standard deviation is 3. So you can type those right in. And you can see I get pretty close. Okay, pretty close. This one's off a little. The first one's off a little because of the rounding with the 2/3 and the 1/3. So it's actually more accurate to use this. But out to 4 decimal places, you can see I get the same value. Okay. On the online calculator, all you would do is just put in your mean and standard deviation instead of the 0 or 1. Here, my mean is 80, my standard deviation is 3. Notice it changes the diagram of the density function to show you the mean in the middle. And here's 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. Okay, here's 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. Okay, so in my example, I wanted a between probability, and I was interested in the scores between 78 and 90. Click recalculate and look at what I got, 0.7471. Okay, so see how to use the calculators with non-standard distributions. Okay, see how to use them with the non-standard distributions. Just plug in your mean and standard deviation. Okay. Alrighty. Pretty much all we have left are examples, examples, examples. Okay, so some of them I'll do with you. Okay, and some of them basically you do. But before we do that, I want to show you one other calculator that I have on here. It's called an inverse normal distribution. Okay, it exists on your TI. Let me bring it up. Okay, see inv norm. Okay, in the normal distribution, you give a score or a standard deviation and you get a probability. Inverse normal does the inverse. You give it a probability and you get a score. Okay, so say I am interested in the inverse normal. I'm interested in the score here, okay, in this distribution. I want to know what score is like 80% of the students below, okay? So I would say 0.80 for area. I'd put in my mean and I'd put in my standard deviation and I click paste and go. Okay, so what this is telling me is 80% of my students, okay, are scoring below 82. Okay, 80% of my students are scoring below 82. Now, the problem with this is if you wanted above, you'd have to do 1 minus this. Okay, you have to do the 1 minus nonsense with the TI-84 because it's only set to give you from the left, from the 0 mark on the distribution out to the right. Okay, whereas with the built-in inverse normal, okay, same lovely online stat book calculators, okay, say I want to know again where 80% of my students in this distribution are scoring, okay, then I just have to click the right box, okay? 80% scoring above a 77.4, 80% score below an 82, 80% scoring between these two values, okay? So again, love the online inverse. Okay, love the online inverse normal calculator because it's so much easier to use. Okay. So again, this one takes a probability and gives you z-scores. The other one takes z-scores and gives you probability. Okay. There aren't a lot of examples on this, but I just wanted to make sure you see it. Okay. It'll definitely come in handy when you do inferential statistics. Okay. So again, let's try some practice. So how about you try these? You try C1 through 4. Okay, use the calculator of your choice. Type done when you finish. Okay, so you try these. Try C1 through 4 and type done when you finish. Okay, again, you've got some information up here, your mean and your standard deviation. Okay, don't calculate z-scores. Use a calculator. You don't need to write down your calculator function because you might be using an online calculator. Just write your probabilities. Okay, type done when you finish all 4 of them. Okay, we'll take maybe another 30 seconds or so. Okay, I realize not everybody may have gotten the answer to all 4 of them, but let's just go through them one at a time. What probability did you get for part 1? Anybody want to type it in or say it? What probability did you get for a score between 120 and 145? Yeah, okay. 0.2006. That's great. Okay. And again, you can use this if you're using the normal calculator. Okay. How about part 2? What probability did you get for 2? Okay, so this was less than 134. And if you look at the distribution, the mean's all the way down at 110. So this would be a really high value, right? 0.9772. Okay, and to do that one, you could have done, again, I'm not plugging the TI, I'm just writing it here because it's easy to write the score, the actual command you would type in. Here you have no lower bound. So you have your faked out negative infinity down there. The highest value you care about is 134. And again, 110 and 12. All right, how about part 3? Anybody get a value for part 3 greater than 128? Yeah, okay, so not that big. Okay, 0.0668 is correct. And again, you would do this by saying your lower value would be 128. Your upper value is the faked positive infinity, and your mean and standard deviation. Okay, and the last one, anybody get a value for that one? Yeah, that's also pretty large. Okay, because that value 96 is below the mean, and we're going all the way to the right. That's a good one. And again, here are 96 is our lower bound. Okay, so again, we have 96, our faked positive infinity, the mean, and the standard deviation. Okay, so I put in the commands that you would use on the TI to do these. Okay, but again, they're much easier, I think, on the online calculator. You just have to remember what box to put stuff in, what circle to click, and then don't forget to hit recalculate. You actually have to poke it to make it recalculate. Okay. So I'm assuming everybody's good with those. The last thing I want to cover today, and I'll do one, you do one, and then when I upload my notes, I'll make sure the third one is also done. But here we have actually applied problems, applied normal probabilities. Okay, so here's an example of some things that could be normally distributed. For example, blood pressure. Okay, your blood pressure, if you've ever had it taken, has two numbers. One, the top number is called systolic, the bottom number is diastolic. I'm not a biology person, but I think one is the force your heart's pumping with, and the other one's the force your arteries pump with. So the higher number is your systolic blood pressure. So we're interested in that number for a group of women, okay? And that blood pressure number is normally distributed with a mean of 120 and a standard deviation of 12. So here's the type of question they could ask you. They could tell you, I've got this normal distribution. Find the probability that a woman selected at random has a blood pressure greater than 140. Okay, so you want to find the probability that X is greater than 140. Okay, so what we need to do here is, if I'm doing it on a TI, I'm going to say normal CDF. Okay, 140 is my lower bound. Okay, and I want to go all the way out. Okay, so there's my faked out positive infinity. The mean of this distribution is 120, and the standard deviation is 12. Okay, so that's how I would do it on a TI. All right. If I were doing this on my online calculator, okay, again, not the inverse normal, but the normal distribution calculator. I can just get to that. There we go. Okay, so I change my mean to 120 and my standard deviation to 12. Okay, and then I'm interested in women that have a blood pressure above 140. I'm going to put 140 in there, click that circle, and click recalculate. Okay, and you can see I get a little bit above 4%. Okay, so 0.0478. And if I were to type in my normal CDF command, I should get the same value. All right. Again, between 110 and 130, that's the probability that X is greater than 110 and less than 130. Okay, so that's normal CDF. Lower bounds 110, upper bounds 130, mean 120, standard deviation 12. And this one I can actually do on the TI for you. Okay, so turn her on. Second VAERS. Okay, my lower bound's 110, upper bound 130, mean 120, standard deviation 12. And that gives me 0.5953. Okay, and again, it'd be real easy to show it on the online calculator because I've already got my mean and standard deviation. I would just say between, and I'd put my between values here, 110, 130. I don't need to change the mean and standard deviation, and you can see I get the same thing. Okay, so again, whichever calculator you're comfortable with, feel free to use that. Okay, so last thing we're going to do is you try question 6 or problem 6. Type done when you're finished. Done when you finish. Okay, so it's again just making sure you can turn the words into probabilities. Okay, you try that one. Okay, we'll wait maybe another half a second, half a minute rather, for folks to finish up. All right, everybody. I know not everyone's done, and that's fine, but let's just come together so we're sure everybody's on the same page with this. So here I have industrial waste that's produced, and it's normally distributed with a mean of 8,000 and a standard deviation of 2,000 tons. If they're asking me for the probability that on any particular day, the amount of industrial waste is less than 6,000, they're asking me for the probability that X is less than 6,000. So one way you can do this is with normal CDF. Your lower limit doesn't exist. Okay, so that would be 1e, negative 1e to the 99, your fake negative infinity. Okay, your upper bound is the 6,000 that you want to be less than. Your mean is 8,000, your standard deviation is 2,000. That's one way to do it on the TI-84. Okay, and you can also do it clicking the below button on the online calculator. And again, what probability did you get for A? What probability did you get for A? Anybody want to just type it in? Okay, 0.1587. Okay, so a little bit more than 15% chance that you would have an industrial waste, daily industrial waste amount less than 6,000 tons. Makes sense, okay? This number is one standard deviation below your mean, okay? So you're only interested in the part of the curve that's to the left of that, okay? The next one is between 9 and 11,000, so that's the probability that your X is greater than 9,000 and at the same time is less than 11,000. Okay, on the normal TI-84, you do normal CDF. Your lower is 9,000, your upper is 11. Oh yeah, I don't type in commas on the TI unless they're separating things. And then your mean is 8,000. Your standard deviation is 2,000. Okay, what value did you get for B? What value did you get for B? Yeah, 0.2417. Okay, and again, if you were doing this on the online calculator, you'd click the between circle. You'd put up 9,000 in the lower value and 11,000 in the upper. Okay, so again, you can see this is pretty straightforward and pretty calculator dependent. So any questions on any of this? Any questions? Everybody okay? Comfortable with the calculators? Comfortable how to use them? I'm going to come back to the meeting. And again, just want to remind you that our Wednesday class will be review for our third exam, our Unit 3 exam. Okay, so please not only come for the review, but also bring any questions you still have. Okay, if you've contacted me through that message instructor link in the homework, I have responded to you. So please, you need to get into the homework and look for the response. If you're not able to find a response, please message me, actually email me again, or tell me, let me know you're not getting the responses, okay? I want to make sure everybody gets their questions answered. Right? And I do that right away. Okay, so don't think, well, she just hasn't gotten to it yet. No, I get to you within a couple of hours at most. All right, so please ask again if you're not getting your questions answered. Okay? Well,